Number 15. 15 numbers are arranged in a row so that the sum of any 4 consecutive numbers is 12. 3 numbers are already given in the respective cells of the row. What number must be in the cell marked by happy face? So we have, wait, can I draw? 我能这个画吗？可我画不出。Okay, 我试一下。Wait, guys, technical difficulties. 你是不是把 touch screen disable？ 你没有把 touch screen disable。哦，它得后面那个呀。好 Okay. All right. So let me draw it. Let me draw the figure out first. Wait, I'm just going to. This is to be continued. Okay, so I can draw a better figure than this, but first off, does anyone want to share how they solved it? And can you guys please check the chat to see if Sophie said something?
Nope.
Okay, nobody wants to share about question 15?
What's happening?
What?
Nothing.
Oh, okay. Wait, I'm just going to... All right, there we go. So this is up to 4 because the screen isn't big enough. And from here, we have 4. 1, 2, 3. There's the happy face. Okay, so now, if none of you guys want to explain question 15, then I'll explain. So first off, it says 15 numbers are arranged in a row so that the sum of any 4 consecutive numbers is 12. So for example, we can, let's just say there are 3 other hypothetical numbers, A, B, and C, and like these numbers, and if we add 1, A, B, and C together, then we get 12. And then it says 3 numbers are already given in their respective cells of the row, 1, 4, and 2. What number must be in the cell marked by happy face? So how are we going to solve this problem? So first off, we want to build up, we want to use A, B, and C to be something like equal to 4. What that means is that we want to represent 4 as the sum of a few variables. So how do we do that? So let's first see, we have 1 plus A plus B plus C equals 12. And now let's look at the next 4. A plus B plus C plus something else is equal to 12. So what must this box be? Well, it has to be 1. Because 1, A, and B, and C together are 12. So we have another 12. So we can keep doing this pattern, and let's look at the next group. We have B, C, 1, and what's missing?
A.
Yes, A. And then so we can continue this, and then C, 1AB, 1ABC. So now we know that C equals 4. And now continuing on, we know that this 4 is a C, and we have A, B, C, and then 1. And after that, we have B, C, 1, and what does the happy face have to be? It has to be A. And then so we can figure out A later, but first off, let's just keep going. And then we have C1AB, B, C, 1, A, B. So now we figured out that B equals 2. So first off, it says that any 4 adjacent numbers all equal to 12. So that means 1 plus A plus 2, which is B, plus 4, which is the C, equals 12. So what does A equal?
5.
Sorry?
5.
Yes, 5. So A equals 5. And what can we tell from this? We said earlier that happy face is equal to 8, which means that happy face is 5. Okay, do you guys get the question now? Do you have any questions about the question? Okay, so now let's see. Question 15 is good now. Now let's go on to question 16. So question 16. Sophie, that's the question that you found interesting, or maybe it was challenging. Okay, so for question 16, does anybody want to read the question out? Okay, well, then I'll read the question. Both figures on the right are formed from the same 5 pieces. One of the pieces is a rectangle with a length of 10 centimeters and a width of 5 centimeters. And the other pieces are quarters of 2 different circles. What is the difference in the perimeter lengths of the figures? Okay, so we have 2 figures. All right, so this is the first figure, and it says that there is a 10 centimeter by 5 centimeter rectangle. And then we have the other figure. Okay, so and it's asking what is the difference in perimeter lengths of the figures? So how do we solve this? Does anybody have any ideas of how do we solve this? No? Nobody? Well, okay. So one way we can solve this is by actually calculating the perimeter of the shapes and looking at, oh, what is the perimeter of this shape? Let's say P1. What is the perimeter of this shape? P2. And then we do P2 minus P1. We get something negative or positive, and then we get the absolute value, which means just turning all negative signs into the positive signs. And then we get the difference. That's one way we can do it. But another faster way we can do this is that we can cross out sections that overlap. What I mean is, for example, since it says that it's the same 5 shapes making up the 2 figures, we know that this arc is equal to this arc. So then we can cross it out. And then we see that this arc is equal to this arc. We can cross that out. And then these 2 arcs, we also have these 2 arcs. So we cross these out. And now what do we have remaining? We have this side remaining. And what is this side? Guys, what is the length of the rectangle?
10.
Yes, 10 centimeters. And now let's look at this shape. So in this shape, we have the rectangle, which is inside, so it doesn't count as the perimeter. And we have the parts of the quarter circles. Oh yes, if you look down onto your paper, or if you look at your questions, whatever, it says that the other pieces are quarter circles. So this, and this are all quarter circles, which means that we know that since the quarter circle, one of the straight edges is 5 centimeters, the other straight edge is also 5 centimeters. And it's the same with the 10 centimeter quarter circles. It's the same. It's the radius. The radius is the same. So now we have 10 plus 10 plus 5 plus 5 minus 10, because we have figure 1, which has all these leftover pieces after we crossed out the curvy parts, and we also have figure 2, and after we cross out the curved parts, we have the straight part left, which is a 10 centimeter. So now this will equal, let's see, 10 plus 10 is 20, 5 plus 5 is 10, this is 30, 30 minus 10 is 20 centimeters. So that is the difference of the two figures. All right, so is there any questions about this question? Give me a yes or a no. Yes? Okay.
No.
No? Okay, what's your question? What's your question?
Don't have a question.
Oh, okay, my bad. Okay, so now we're done question 16. Now let's do question 18. Okay, so question 18. Does anybody want to read this question? If you want to read it, just go straight ahead and read it.
So you can choose any two triangles and overlap them as you want. Which one of the following polygons cannot be the shape of the overlapping part?
Okay, good. So we have two triangles, and then they can overlap. And then so which of the following polygons cannot be the shape of the overlapping part? So let's first think about how we're going to solve this problem. So the first way we can solve this problem is by trying all the possibilities, and we see which one we don't have. Or in other words, we just try different possibilities until we find all the shapes, or until we can't find one shape. So we can do that. For example, let's look for triangles. We can have a big triangle and a small triangle inside it. So this is an overlapping part, which means that A is not the answer, that we can overlap to form a triangle. Now let's try and form a quadrilateral. Let's see how we're going to form a quadrilateral. This will work, so we can cross out B. And then for C, a pentagon. Let's try a pentagon. If we intersect it in the side with another triangle, this is a triangle, so no. And let's try another possibility. Like this is a quadrilateral, so no. And then, so if you keep trying, you will find out that the way to get a pentagon is by doing this. See, 1, 2, 3, 4, and 5. So we can cross out C. And now a hexagon. How are we going to get a hexagon? We can elaborate on this figure, and then we can, let's see. So how are there more sides than usual? See, we first started off with a triangle inside another triangle. This is only a triangle. And if one angle pokes out, this is a quadrilateral. And if two angles poke out, it's a pentagon. So alas, if we have three angles pointing out, we have a hexagon. So which means the answer is E. Any of the polygons in A, B, C, D can be obtained. So let's say that we can't find out one of the shapes. So if you're doing a test and there's very limited time and you just want to hurry up, you might as well just choose the option that you think it's impossible to form. Otherwise, if you still have some time, you can think of a reason for why the shape cannot be formed. So that's another way you can solve this if one of the shapes seems like they can't be formed. So do you guys have any questions about that question? Okay, I'll take the silence as a no. So question 19. Question 19. Does anybody want to read the question? No? Okay, I'll just read it then. A rubber ball falls vertically from the roof of a house at a height of 10 meters. Okay, and then after each impact on the ground, it bounces up to 4/5 of its original height. So what is 4/5 of 10, guys?
8.
Yes, 8. So it bounces up to 8 meters. And then it bounces down, it bounces up again, it bounces down, and so on. So now it's asking how many times will the ball appear in front of a rectangular window whose bottom edge is at height 5 and whose top edge is at height 6 meters, 5 meters, and 6 meters. How many times will it pass it? So we can do this by just thinking it through. So for example, first off, it drops from 10 meters. So if it drops from 10 meters, it's going to pass the window when it drops. So that is 1 time. And then when it bounces back up 8 meters, it passes the window again. So that's another 1 time. But then it drops down. So that's 2 times. And so 4/5 of 8 is 32/5, 32/5. So how much is 32/5? Well, we need to know if the ball goes up to higher than 6 meters, between 6 and 5 meters, or lower than 5 meters. That's all that matters. We know that 6 meters is 30/5 meters. And 5 meters is 25/5 meters. Which means we see that on the second time it goes up, it goes past the 6 meter point, which means that it passes the window and it goes up and then it falls down, which means it's another 2 times. Okay, wait, let me just erase some things. Okay, so after the 32/5, we multiply it by 4/5 to get 128/25. So for 128 over 25, that's how high we will jump. And is it between 5 meters and 6 meters, or is it above 6 meters, or is it below 5 meters? Now we know that 25 times 5 is 125, which means that 128 is just a tiny bit higher than the 5 meter point, which means that it will pass not halfway, just right above the window, not right above. It'll pass over the window, and then it'll drop when it's still visible through the window, which means that it'll go up to 5 point something meters and it'll drop down again, which means you only get to see it occur once. So that's one time. Okay, so now let's keep going with this structure. 128 over 25 times 4 over 25. No, 5. And then so this way we get 512 over 125. So 512 over 125, let's see. So 125 times 5 is equal to 625, which means that the 5 meter mark is 625 over 125 meters. And 512 is smaller than 625, which means that it does not pass the window this time. And since it jumps up lower and lower every time, then we know that it will never pass the window again. So we have 1 plus 2 plus 2 plus 1 times, which equals 6 times. So do we have any questions? All right. So, wait, Yuki, which question were you talking about? Question 19? Are you muted?
Yeah, it's question 19.
Question 19. So, the answers, I don't know if it's the same with your paper, but on my paper, it's A3, B4, C5, D6, and E8.
Yeah, it's the same.
Okay. And then, so what, yes?
Like, I thought it was only one time.
What do you mean? You mean like it was 1?
Yeah, like, I thought it was 1.
Wait, did my audio cut off or something?
No, I
Oh, you
just
thought it was 1.
before. Yeah.
Before, okay. Yeah. So, well, we just saw that since it dropped down once, it was 1 time, and then it went up and dropped down 2 more times. It went up, dropped down another, which means it passed the window another 2 times, and then it went up and went down in front of the window, which makes it 1 time. So these added together is 6. So does that clarify your question?
Yeah.
Okay, good. All right. So now we have question 21. Oh, okay. Okay, you guys, also, let me just tell you guys something. You guys can unmute yourself and talk at whatever moment you want. I'm not really strict. I won't limit you into only talking during my questions time, because like if I just explain and you don't understand something from one point on, then I'm going to have to re-explain again. So I'd rather you guys interrupt me. Now, question 21. Weenies, vinegar, wine, water, marinade contains vinegar and wine in the ratio 1:2, and wine and water in the ratio 3:1. Which of the following statements is true? A. There is more vinegar than wine. B. There is more wine than vinegar and water together. C. There is more vinegar than wine and water together. D. There is more water than vinegar and wine together. E. There is less vinegar than either water or wine. All right, so before we go into these confusing answers, because it sounds confusing when I read it, let's first get the proportions right. So first off, this is vinegar to wine, V to WI, and then this is the 3:1 is wine to water. So we want to get the ratio between vinegar and water. How are we going to do that? First off, we see that there is something common between them. There's the ratio to wine. So let's see. We want to get the ratio of wine to become the same. So this way we can compare vinegar with water. Because for example, we have this is for example, there is 1 drop of vinegar for every 2 drops of wine. There is 3 drops of wine for every 1 drop of water, which means that if we make the amount of wine in both ratios something common, we can compare the amount of vinegar to the amount of water. So let's see, 2 and 3, we need to make them 2 common numbers. A common multiple. We need to find a common multiple. So the least common multiple of 2 and 3 is 6. So 6. So we know that for every 1 drop of wine, 1 drop of vinegar, there are 2 drops of wine. So if we triple that, we have every 3 drops of vinegar to every 6 drops of wine. And we can do the same thing here. It's a 6:2 ratio. And now we can write them together. For every 3 drops of vinegar, there are 6 drops of wine, and there are 2 drops of water. Yeah, so now let's look at the options. A, there is more vinegar than wine. Let's see, vinegar and wine. Wine, there's clearly more wine, so no, not A. And B, there is more wine than vinegar and water together. So let's see, wine. So wine is 6 droplets, and vinegar and water is 5 droplets. So that's true, which means the answer is B. Okay. Oh, 不小心点了. All right. So did you guys get it? Do you guys get the question? Do you guys know how to solve it now? Oh, okay, good. Okay, so now to question 22. Question 22. Let me draw the figure first. Does anybody want to read it? All right, fine, I'll read it. 22. Peter wants to cut a rectangle of size 6 times 7. So 6 times 7 rectangle. Seven. With phalanx represented by integer numbers. What is the minimal number of squares he can get? So How are we going to solve this question? Well, let's see. We definitely couldn't use a 7 times 7. What about if we use a 6 by 6? There is only one there's only one possibility for using a 6 by 6 because it's symmetrical if you do it on either sides. What I mean is that we can have a 6 by 6 here, or we could have a 6 by 6 here. But does it make a difference? Not really. So that's what I mean by there's only one possibility. So let's see. If we only have one 6 by 6, how many squares would we need? So we need the one 6 by 6, and then we need 6 more squares, 6 more 1 by 1s, which equals 7 squares. So then we know that 6 by 6, if there's a 6 by 6, then we need to use 7 squares. And now let's see, 5 by 5. What if we use a 5 by 5? So for 5 by 5, let's see how many possibilities are there. So there's a possibility we have the corner with the 5 by 5. What I mean is like right here. Can you guys see? I think you guys can. What I'm trying to color in this 5 by 5. This let's just call this the corner 5 by 5. And then we also have the side 5 by 5, which is this 5 by 5. So for these two 5 by 5s, this corner 5 by 5, we can see that there are side lengths, we can form side length 2 squares. So we have a 2 by 2, another 2 by 2, and another 2 by 2. We also have a few 1 by 1s. So we can therefore have 1 5 by 5 plus 3 2 by 2s plus 5 1 by 1s. This is 9 squares. This does not beat the 7 square. Now let's look at the other possibility. So for the other possibility, we can clearly see that we need to use more than 9 squares, since there are 1, 2, 3, 4, 5, 6, 7, 8, 9, and more 1 by 1 squares on the outside. So currently, our lowest number is 7 squares. So let me just erase everything. Okay. Now we have 4 by 4s. So let me just draw the rectangle first. 1, 2, 4, 5. All right. So 4 by 4. So we can first do the corner 4 by 4, which means this 4 by 4. So if we have the corner 4 by 4, let's see. We have something of width 3 here. And we also have another width 3 square. And we have two 2 by 2s. So 1 plus 2 plus 2 equals 5 squares. And now, let's see. We don't have to do the corner one. We can also do the side one, which is this square. And now let's see. Well, clearly we see that there are 1, 2, 3, 4, 5, 6, 7, and more. So we already know that it's going to be more than the corner 4 by 4. So, and then there's also the center 4 by 4. Let me show you. Just gotta erase this. All right, so for the center 4x4, what I mean by that is that it doesn't touch any edges. So we have the center 4x4. All right, let's see the center 4x4. There's 1, 2, 3, 4, 5, 6, 7, 8, a ton of 1x1 squares. So that's not going to work. And did I forget any possibilities? Did I, guys? Did I forget any possibilities for the 4x4s? Yes, I did. Okay, so there's this possibility, another possibility that is on this edge. So for this possibility, let's see, there's 1, 2, 3, 4, 5, 6, 7, 8, 9. There's got to be more than 9 squares. So we can cross that out too. And what about 3x3s? Well, we already used 3x3 in our 4x4 ones, so it's not that necessary to use to try the 3x3s, but let's just try them just to be safe. All right, so we have 1 3x3, 2 3x3s, and let's see, how do we do this part? We have 2x2s, but remember, we want to be able to use four squares. And if we're looking for a possibility of 4 squares, we know that if we only use 3x3s, 2x2s, and 1x1s, we can, if we use 4 3x3s, then it doesn't cover the entire rectangle. So which means that we have to use a 4x4, a 5x5, a 6x6, or 7x7 if we want to only use 4 squares. And since we tested all these possibilities, and we saw that the lowest number of squares is 5, then that'll be our answer, 5. Okay, so do you guys have any questions about that problem? All right, I'll take the silence as a no, like always. And now, 24. 12 numbers from 1 to 12 are arranged in a circle so that any neighboring numbers always differ by either 1 or 2. Which of the following pairs of numbers have to be neighbors? So we have 1, 2, 3. 1, 2, 3. All right, so we have this circle, and how are we going to solve this? Does anybody have any ideas of how we're going to solve this problem? No? All right. So first off, let's start by placing 1. Because it says that the neighboring numbers always differ by 1 or 2. So +1 or +2 or -1 or -2. But since there are no negative numbers or 0 in the list, we know that we already know the 2 neighbors of 1. So one of the neighbors is 2, we can place it wherever we want, and another is 3. So now let's solve this. So for 2, what neighbors does 2 have? 2 has 2 plus 1, 3, 2 plus 2, 4, 2 minus 1, 1, and 2 minus 2, 0, which we don't have 0. So 2 can be neighbors with 3, 1, or 4. But we know that 3 is already on the other side of 2, which doesn't count as a neighbor. So we have only 4 left, since we already used 1. So we have 4. And we can do the same thing with 3. So for 3, the neighbors are 1, 2, 4, 5. 1, 2, and 4 are all out, so we have to use 5. And we can continue the pattern, and you see that on one side we have the odd numbers, and on the other side we have the even numbers. So now, this is pretty easy. We just have to look at the options in the answers and see which ones are even with even or odd with odd, or else if it's not like that, they have to have 12 or 1 in them. We see that there's 8 and 10, and 8 and 10 are even and even, which means that they must be neighbors. Okay, do you guys get it? Number 25. All right, can somebody read this, please? You guys haven't talked for a long time.
Several cells of a 4x4 table were colored gray. Number of gray cells in each row was indicated to the right of it. Number of gray cells in each column was indicated at the bottom of it. Then the gray color was washed down. Which of the following tables can be the result?
Good. So that's the way of solving this, because there's not really a lot of ways to solve this problem. So the way that usually works is we just try every option. 4, 2, 1, 1, 2, 3, 3, 0. So this is the first option. So right away we see a 4, which means that all 4 of these squares are colored in. But the thing is, this is a 0, which means that the 0 cannot have anything in its column. But since we already have something in its column, and we can't remove this thing, since this is a 4, this makes a paradox, which means it cannot happen. So we can just erase that. All right, so now going on to the next one. 1, 2, 1, 3, 1, 3, 2, 2. So what is the problem with this one? Can anybody find any flaws within this figure? You can't? Well, so first off, let's see. We know that the four numbers for the rows and the 4 numbers in the columns actually indicate the total. When you add them together, they are actually the total amount of dots. Since, for example, if we have 2 here, 2 here, 3 here, and 1 here, see, we have 2 plus 2 plus 3 plus 1, which is 8. And we have 1 plus 2 plus 1 plus 3, which is 7. But a figure can't have 7 dots and 8 dots at the same time. So that's a problem there. All right. So now C. 3, 3, 0, 0, 3, 1, 1, 1. Can anybody find a problem here? And here's a hint. It's similar to A. Similar to A's problem, where A had a row of 4, but also had a column of 0. So you guys can try and find the problem. And you guys can just open your mics and tell me what's the problem with this figure whenever you want.
Well, for the column, this is 3. That means out of the column, there must be 3 that are shaded. But there's 2 zeros there, so you can only shade 2, but you need 3.
Yeah, so since there are 2 zeros in the rows, it means that for this column, for all these columns, it has to be a 2 or a 1 or a 0. But this one's a 3, and that makes a paradox. So yes, that's correct. All right. D. 2, 1, 2, 2, 2, 2, 1, 2. So let's see this. How can we solve this? Let's see. So if we have a 2, for example, let's just dot 2 of them. And then we have a 1, you can, for example, do this one. We have 2, these 2, And we have another 2, which is this one and this one. Oh, look, it makes the figure. So we know that these numbers and these numbers, when you add them together, these two have the same sum. And also, there are no zero paradoxes. So now that works. Okay, so now that we've got that done, and just to make sure, let's look at E, okay, guys? Now this time I want you guys to tell me again what the problem is. Zero, 3, 3, 1, 3, 1, 3, 0. What is the
In
problem?
the row, there's 2 3s.
Mm-hmm.
So that means you can't put one of the 3s in the 0 in the bottom of the column, like in the row.
Yeah.
You need to put it there. But there's another 3, you can't put it in the 0 column. But there's only one for the there's only one in the row, in the column. Yeah.
Yeah. So basically the 0 parts are almost like you just cross this part out and it's a 3 by 3. And we see that there are 2 3s, which is basically, if we have the big picture one, it basically is like 2 4s and a 1. So it doesn't make sense. So does anybody have any questions about this question, this problem?
No.
Okay. Now, question 26. Adam's house number has 3 digits. Removing the leftmost digit of this number, you obtain the house number of Adam's friend, Ben. Removing the leftmost digit of Ben's house number, you obtain the house number of Chiara, whatever, C. The sum of the 3 house numbers is 912. What is the middle digit of Adam's house number? So, for example, we have A, B, C. Let's just say this is Adam's house number. Remove the leftmost digit of this number, BC. And then if we remove the leftmost digit of Ben's number, we get C's number. So let's add them. If we add them, we get 912. And it's asking, what does B equal? B equals what? All right, so how are we going to solve this problem? First off, we see that we have an A up here, and we have 2 B's here, which means that we know that 2 times any digit is going to be smaller than 20. Why? Because 10 is the smallest number that is not a digit. So we know that A must equal 9 or 8. So let's say A equals 9. And then that means B have to be 0. And then if B is 0, we see that BC is 0C. The number is 0C. But Ben's number can't be as well, like in this problem, the house addresses cannot be zeros. Wait, actually, never mind. Well, let's just say that that the second digit could be a 0. So if it could be a 0, then we have 0, 0, and then we have C is 4, 4, and 4, which means that B equals 0, and the answer is D. But wait, what if we used 8? So if A equals 8, and then we have 2 numbers, B and B, and B plus B must equal 10. Or if it equaled 8, then that means the C plus C plus C must equal a 32. But if C was 10, 10 times 3 equals 30. That's still less than 32, which means that B plus B must equal 10, and B must equal 5. So if we have 5 plus 5, and then we have a 9, 0, 0. And then we must need another 12. So C is still 4, which means that technically there are 2 answers. But on the answer key, it says the right answer is A. But they didn't say that the house numbers, house numbers with 2 digits can't have a 0 as its first digit. So strictly saying, this problem is a strange problem and it has 2 answers. But for this for like the designing purpose of the problem, they just say that, oh, a house number cannot start with a 0. So if we take that into account, then that means the answer must be A. But then it's strange how there's also an answer D. Well, there shouldn't be an answer D anyways. There shouldn't, if your house can't begin with 0, then the answer, then a choice for the answer should not be 0. So we don't know about this question. This question is a strange question as it's from the ancient 2012, and in 2020, questions make much more sense. So do you guys have any questions about this strange problem 26? Okay, so now let's work our way backwards. Okay, so since we're almost out of time, I'm just going to tell you guys the correct answer of the paper if you guys want to know the correct answers and correct yourself. So can you guys scroll to number 8? Say I'm done when you've got to number 8.
I'm done.
All right. Yes. And then, so number 8. Number 8, the answer is A. And then number 9, the answer is B. 10A. 11D. 12B. 13C. 14A. 15D. 16D. 17C. 18E. What?
What was 13 again?
13?
Yeah.
13 was C.
Okay, thanks.
No problem. All right. So we were on 18. And 18 was E. 19 was D. 20 is also D. And 21 is B. 22 is also B. 23 is A. 24 is C. 25 is D. And 26 is A, but strictly speaking, it could be A or it could be D. All right, so now we have some math riddles. They're not really math. They're just trying to troll you. These are troll riddles. So like, if you can't figure it out, it's okay. All right, so we have one of them, which is called 5 apples. 5 apples are in a basket. How do you divide them among 5 girls so that each girl gets an apple, but 1 apple remains in the basket? So does anybody have any ideas on how to solve this supposed math problem? Does anybody have any ideas of the answer? 这个，啊，哦，他这个 chat 里面是不是说了啥呀？哦
那它在哪里？
，chat，
我在这看 more 呢。The chat.
okay. Here's an answer, like kill the fifth girl, but that won't work, right?
It's a lot more speed.
5 divided by 5 equals 1. Okay, so some of you guys say that 5 divided by 5 equals 1. Yeah, well, each girl gets an apple, but you need another apple in the basket. Yeah, I know 5 divided by 5 is 1, but it's saying that there are 5 girls and each girl needs an apple, but 1 apple remains in the basket. So there are 5 apples plus 1 apple is 6 apple. Yeah, okay, get another apple. Yeah, okay, yeah, that's fair. Now let's look at, you guys can think about it when you get home. So now let's look at the other question. Don't think too long. How many cats are in a small room if in each of the 4 corners a cat is sitting? And opposite each cat there sit 3 cats, and at each cat's tail a cat is sitting.
A lot of cats.
4.
Yeah, okay. 4. Okay, how do you know it's 4?
Well, just I don't know. I've heard this show before. I think it was 4.
The answer is a lot. No,
Well, yeah, that works too.
Yeah, okay. Well, you guys can think about it when you get home as time is up. So